in this section, I have changed the topology a little bit. I want to show you something about NSSA areas. Here you can see that I have changed the topology a little bit. Here, router 9, the connection between router 9 and router 8 is shut down, so there is no connection between these two. I have put router 9 in an EIGRP autonomous system. The autonomous system number is 100. And so this is going to be an external domain to our OSPF network. So what I'm going to do is this. I have put router 4 and router 10 in 104. Area 104 is for these two. And you can see that router 10 is in area 104 and it is connected to EIGRP domain. So if we have not anything to do with any type of stub domain, you can see that I am removing this because I want to show you that this is going to be a normal domain. Here, if I have area 104 as a normal domain, that's going to be okay. That's because it is connected to area 0. It can redistribute every route from an external domain into itself, and it can, put those through the router 4 that's an ABR to area 0, and it can inject them into area 0, and area 0 is going to redistribute this to every place. Let's check this configuration first. I have done most of the configuration, and you can just go for the results. Let's go to router 9. Here, show IP protocol tells me that I have only EIGRP 100, and you can see that I have injected a lot of interfaces here. I have 3 loopback interfaces here with 32-bit mask, and I have put them under EIGRP process, so they can be in EIGRP topology table. So let's go to router 10. Router 10 is connected to router 9. Here, if I show IP protocol result, you can see that I have OSPF and EIGRP, and it tells me that I have redistributed EIGRP 100 into OSPF, and at the same time I'm doing this the redistribution from EIGRP, including all subnets. But that means actually I'm redistributing classlessly into OSPF. So I have mutual redistribution enabled on these two on router 10. So you can see that these two domains can have information about each other. And let's go back to the configuration. You can see that all of the areas are normal areas. So let's go to router 9 and check IP routing table. Show IP route tells me that I have full information about the whole network, and I have received all of those information from router 10. And actually all of them are external routes and EIGRP external routes, and I have received all of them from router 10, and router 10 is the redistribution point to my autonomous system. So let's try a ping. If I try to ping, for example, 100, 100, that is loopback 0 of router 1, you can see the ping is successful. And I can make sure that router 1 knows about my loopback interfaces. For example, I have a loopback 91, so I source this from loopback 91. You can see that the ping again is successful. So I have everything here, and my routes are redistributed to other areas. Let's go to router 1 that is in area 12, I guess. Yes. And check the IP OSPF database here. By checking IP OSPF database, you can see that I have some summary routes, some summary LSAs, and some type 5 LSAs. And this type 5 LSA is a new LSA type. That's external link that is redistributed from router 10. As you can see here, the advertising router is router 10. So type 5 LSA is a type of LSA that is created using the redistributing router, and it contains a lot of external routes such as these that you can see here, and they are injected into OSPF and they are forwarded using the ABR to other routers, other areas, and every area in my OSPF network should know about these external routes. Now let's go back to our topology here. Again, I have a lot of routes on router 10. I don't want to have so many routes on router 10. I know that router 10 has only one exit point, and that exit point is actually router 4. So why would I have so many routes in my routing table and process all of them while I do not need them? So to this, I can change this area to a type of a stub area. But I know that the stub area does not allow redistribution. Stub area cannot connect to external. Of course, it can connect to external domains, but it cannot redistribute the routes from that external domain into other areas. So the type of area that I need here is a not so stubby area. A not so stubby area is actually a stub area, but not so stubby. That means it is stub, but it can have redistribution. It can have information from other domains, and it can give those information into the to the ABR, and ABR can receive them. So let's go and do this. I need to configure router 4 and router 10 to make 104 an NSSA area. So let's go to router 10. I go to configuration. Let's clear the screen, that's better. Go to router OSPF 1, and here I type area 104 as an NSSA area. I should do the same thing in router 4. So let's go to router 4 and configuration, go to router OSPF 1 and type the same command here. You should see a resynchronization, and now the adjacency is created between these two routers. So let's go to router 10 and check IP-OSPF database and see what happens here. If I check IP-OSPF database, now you can see I have information from router 4, and actually router 4 is the only ABR that I have here. I have some type 7 LSAs, and this is opposing the type 5 LSAs that I had originated previously. You can see that I have timed out all of them. They are all over 600 seconds, but here you can see that all of them are regenerated using a type 7 LSA, and type 7 LSA has full information about loopback interfaces on router 9, that is an EIGRP domain. So let's execute this command again. Now you can see that the only routes that are timed out, they are routes in type 5 external LSA. So we have created a new type of LSA, that's type 7. Type 7 is an external link, exactly the same as type 5 is, but type 7 is created using a not so stubby redistributing router. Okay, now let's go to the other areas. I want to check to see if I have information about these routes on the other routers. So let's go to router 1, for example, and execute this command again, show IP-OSPF database. Now you can see that I have information about them again as type 5, and this type 5 is generated using router 4. So everything is working just fine. I have changed router 10 and router 4 as an NSSA router for area 104, and everything is working just fine. So what happens if I want to remove all of these routes? I do not want to have exact prefixes for the destination, and I want to tell you why we have two types of NSSA and two types of sub areas. But this is going to, be discussing in CCIE, of course. But here I want to give you some hints about when you should go for having a totally stubby and a sub area, even in NSSA or a normal sub area. Okay, so I just want to change this to no summary. Using a no summary, it gives me some information. That means I do not want to receive all of these summary LSSAs. Actually, it changes this NSSA area into a not so stubby, a totally not so stubby area. So let's execute this command again. Here I add no summary. Of course, this should go to router 4 because router 4 is generating summary LSAs. Router 10 has nothing to do with that, but we can, of course, add this command to every place in our NSSA network. So let's go to router 4 and execute this and add no summary and tell router 4 not to send any summary information to this area. Now if I go to router 10 and check this command again, show IP OSPF database, you can see that I have removed every summary network, every summary LSA, and the only thing that I have is a default information generated into my area. Now again, I am sending every information using type 7 LSAs. Again, if I go to router 1, for example, that is in area 12, I should see every information about these networks using type 5 LSAs. And that's quite true. And again, if I go to router 9 and try to ping, for example, router 1 using my source, using loopback 91 as my source, again, it should be successful. So everything is working just fine. Now, we know that we can have stub and totally stubby. Let me show you something here. I want to draw this for you. Assuming that I have, for example, that this is not a good color. So let's go to paint and do this here. Assuming that I have only one exit point, here is one area. Yeah, that's a better option. Here is one area, here is another area, and this area is going to be an NSSA area, and this is my router here. Okay, now I have this router here, and this is the only exit point to all of these routers, and these are routers in area, for example, area 0. And if I have such a configuration here, let me do this again. I want to draw and I want to talk at the same time, and that's going to be a problem. Okay, now you can see that I have only one exit point to this stub area. So it doesn't matter if I send every summary information to this area. I only need a default route. But what happens if I have two ABRs here? Assuming that, for example, I have another area, and this area should be area brown, and I have this area here connected to these two, for example, and I have a router here that's going to be another ABR, and now this ABR is, for example, connected to this router like this. Oh my god, I want to select a line, but it is not working. Okay, now you can see that I have two ABRs here. So when I have two ABRs, I can select one of the ABRs to to stop sending every summary, and the other area to, for example, issue summaries. So this should be a no summary, a totally stubby router, a totally stubby ABR. This one can still send summary information into my stub area. So we can have two exit points. One of them is sending the longest prefixes into my area. So I will choose this as an exit point, but the other one is sending only a summary, only default information into my network. So this way, when we have two or more ABRs into our stub area, we can select one of them to, as a better exit point, with not choosing to have a totally stubby configuration on that. But the other one can be a totally stubby router, a totally stubby ABR actually, with no summary option, and this will only generate the default information. In case that we lose one of these routers, the other is going to take the responsibility and forward the information into other areas. So this is the reason that we go for no summary, or in some cases we are not using no summary. But we are going to talk about this when we are talking about CCIE level OSPF configuration. Okay, now you can see that I have everything about different area types. In next section, I want to talk about filtering in OSPF. Actually, what I'm going to do is to change area 12. And you can see that area 12 has two different ABRs. One is router 2 and one is router 3. And I want to use these ABRs to filter some LSAs into or out of area 12. And you will see how can we use filtering mechanisms in OSPF.